All right, good morning, everyone. I am with you today, so I'm going to be presenting this lesson through Screencastify. So I need you to be on your best behavior, and I need you to take some good notes here, and then you will, at the end of those notes, you'll have an opportunity to show what you've learned and do that through an ed puzzle that has to do with our lesson today. And there's also going to be some Delta math practice time for you. So that is what our day looks like. Let's start with our notes. One thing I wanted to point out really quick is that there is a properties of exponents rule sheet that I uploaded for you. So if you click on that, you should be able to open up this rule sheet. So let's quick do that so you can just see what I'm talking about. If I was a student, I would have this out as it has the rules that you need. Okay, I have one in front of me. So for you in-person students, um, eventually I will have those for you in person, and I'll just hand them to you so you can have those out on your desk to help you. But for now, everybody can have this right here, and they should be able to have it out and look at it and see what's going on. And it kind of tells you each property and what you're supposed to do. So, yeah, once you study it a little bit, it'll make sense and it'll help you. So I would have that out as I do this work. All right, so we're going to review really quick some of the ones we've already covered. I know some of this we've already done. This says product of a power's property. So really that means, remember, product means multiply. And so whenever we have same bases and we're multiplying those bases, we would add those exponents, okay? So add those exponents. So this is something that you've already written. It's just a really quick review, just so you see. So this is a time sign, right? And if we have these here like this, we would say that we will be adding the exponents. The bases stay the same. So this is a time sign right here you might see, and this is a time sign as well, but we are adding the exponents. All right. And then down here, it says when we're dividing powers, this is called the quotient of powers property. When we're dividing powers, you subtract the exponent. So I have subtract circled right here. And we would be subtracting. So the answer here would be A as the base M minus N. And this is something we've covered all last week. And you will have to continue to know how to do this. And then these were just some practice ones that we did. Remember, we had the bases the same, and we would add when we're multiplying. Same with this one, we have the sevens are the base the same. 3 plus 5 gives us 8. Whenever there isn't any exponent, remember there is a 1. So we have 9 plus 1, and we get 10. We're adding those exponents when we're multiplying. And then this is an interesting one. I really want you to see this when there's nothing, again, in between here. So there is nothing. There's just parentheses in between here. That means multiply as well, remember? And so they have the same bases. The base is -7. We would be adding 2 plus 1, and we get 3. Out of the way. There you go, 3. Okay, so product of the powers practice. That's what that was. And then this one is the quotient of powers practice. We did this one as well. Remember, whenever you're dividing, you subtract the exponents. I want you to get really good at this. So these are ones that we did before. At any time, the teacher can pause this. So please let them know if you need to write some of this down because you forgot it from last week, or you didn't get it, or you wanted to discuss any of this. Please pause the video or have the teacher pause the video, ask them to. But again, we did do this stuff last week, okay? All right, let's talk about this one. This one we also did last week. It says to find a power of a power, which means like a power raised to a power. So there are 2 of them. You would be multiplying their exponents. And I always tried to tell you that, hey, we've got parentheses here. And so the exponents you would multiply. So let's just put an example down. If I have 3 as the base, and maybe I have 3 to the second power, and I'm raising it to another 3, that would be the same as 3 to the sixth power because 2 times 3 gives me 6. Okay, and well, let's go look at some of those really quick. We did these again last week. So x is the base, we do 2 times 4. 2 is the base, 3 times 4 gives me 12. And negative 2 is the base again, 2 times 4 gives me 8. So because of those parentheses, power to another power, we are multiplying the exponents. So right now we've covered adding some of the exponents, we've subtracted the exponents, and now we've multiplied the exponents. I'm going to go back to this one down here now. This is something new, so please pay attention. It's only slightly new because it's just a little bit different. It says to find a power of a product. Okay, so here's a product, multiplication. It says blank the exponent. And basically what you're doing is you're distributing the exponent. So I'm going to write down distribute. And again, distribute means multiply. So this is very close to the other one. It's just saying, hey, we've got each of those. So distribute the exponent to all terms of the product, or all, we can even say items of the product, everything that's being multiplied there. Okay. So you distribute it to them, and then you're multiplying. So let's talk about this. Again, this is one to write down. This will be new, so this one should go in your notes. Your teacher can write this, can have you pause the video at this point. But let's take a look here. This is A to the M, and then it's B to the M as well. So the parentheses are now gone, and M simply got distributed to each of those items inside the parentheses. Okay? So again, I encourage you to pause the video now and get some questions answered. Okay, over here now, let's do some practice. So these are different ones. I'm gonna go over here, I think. Okay, let's take a look here. This says x, y, z all to the fourth power. So again, we're applying or distributing this 4 to each of these. And since there is an invisible 1 on here, it's just 1 times 4. So each of these will just have a 4 on it. That is going to be your answer. X to the fourth, Y to the fourth, and Z to the fourth. And that's it. So you're just distributing it to each of those. If there is no exponent, it simply goes on it, right? Because there's an invisible exponent of 1. Same idea for B here. It's 4 to the third power and x to the third power. You could simplify this a little further, right? By taking this 4 and actually putting it in your calculator, right? 4 to the third power. You could do that. And you can simplify that further, especially if they say fully simplify. But for now, I'm just trying to show you that the 3 goes to each of these. All right. Over here, the same idea. The 2 now will go to the x, and the 2 will go to the 4. It's actually a negative 4, though, so we got to make sure we do that. Let's write this below here. Negative 4, then. And this one is still in parentheses, which is just fine, to the second power. And then we have x squared. Let's quick do this math. This one isn't too hard. Negative 4 to the second power, what is that? Typing that in your calculator. It's as easy as negative 4 times negative 4, which will give you 16. And so our final answer would be 16x squared. Okay. The reason why I wanted to do that one is because this one looks really similar, right? If we look over here at D, it looks very similar. The only difference is the negative on the outside of the parentheses. So let's distribute this 2 again to each of the items inside here. So it becomes, again, a negative on the outside. The parentheses this time would fall off then. we have 4 squared, and then we have x squared. If I'm doing this math, I have 4 to the second power, gives me 16. I bring down this negative now, so it becomes a negative 16 x squared. So there's the difference. The negative on the outside means that, hey, this answer is going to be negative. The negative on the inside doesn't necessarily mean it's going to be negative, okay? Because a negative times a negative equals a positive. Those negatives would cancel out. So anytime you have an even number as the exponent, those negatives would cancel out. All right, I'm going to encourage the teacher to pause the video here and make sure that everybody has this written down. Maybe you could type like G into the chat when you have this example. And again, I would encourage you to look back over this sheet. If you look over here at this sheet, um, let's see here, which one is that one? That one would be the power property. That would be the second one. So if you go back to that sheet, I could do that here as well. This properties of exponent sheet right there, you could look and see, oh yeah, that's what it looks like. So I want to encourage the teacher to pause it and just check in with you guys, make sure you guys are all good before we move forward. All right, the next one is called power of a quotient property. This one's similar, right? We have parentheses and we have a division thing going on, but look, the bases are different. But you're going to do the same thing. We're going to distribute, and I'm not even going to write these in here. It's the same as the previous thing, so don't worry about writing this rule down. The whole idea, again, is the same thing as the previous one, where we would distribute, but this time we're doing it on top of the numerator or the top part of the fraction and the denominator or the bottom part, right? So now this would simply be a to the m power over b to the m power. So again, it is multiplication because of those parentheses. It is distributing. It's the same idea, okay? Let's give you one more. Let's do it with, if I have 3 over x, and I have parentheses, and I have I don't know, maybe just a 2 on the outside of the exponent. Again, we would just distribute the 2 to each of these, and so we would have 3 squared over x squared. And again, you can do the math of 3 squared by taking 3 times 3, right? And we get 9 over x squared, if we wanted to totally simplify that. All right, let's go take a look at some examples now. And again, if you need to pause it, please pause the video. Okay, so the 3 goes to the x, the 3 goes to the y. That's it. X to the third power over y to the third power. Done. We're just distributing the 3. Similarly, we have a 2 here, right? And we have the 2 getting to each of these items. Remember, if I'm going kind of fast, you can always pause the video. You can talk about it. This is a newer one, but it's only slightly new. The parentheses is similar to what we've covered in the past. So we can do this math. We have 3 squared, which is 9, and 2 squared, which is 4. So our final answer would be 9 over 4, and you just leave it as that fraction. Okay? Let's take a look over here now at C. We have a negative, which is okay. We're going to just move that negative to the 7. And we're going to, again, distribute that 2 to each of the items inside those parentheses. So it's going to be negative 7 squared over x squared. And then you can do the math for that. Again, the calculator will do the work, or maybe you know this by heart. What is negative 7 times negative 7? That would give you 49, right? Over x squared. All right, and then we go to D, which is very similar because then we have the negative on the outside. That should tell you something. Anybody remember what that means when the negative is on the outside? It would mean, yeah, yes, your answer is going to be negative. So just remember that. Let's distribute this. And I really like this problem because look, we have this 2 for the exponent on the outside, and it goes to the 7 again. But at this time, it goes to the 3 as well. So let's see what we would get. The negative stays, and we do 7 to the second power over x to the, what am I going to do now? I have a 3 there, and now I'm having a 2 here being distributed to it. Well, distributed means multiply, right? So 3 times 2 gives us 6. So that's how many x's we would have. All right. And our final answer then we could say would be, well, negative 49. And the reason again is 7 squared is 49. And we bring the negative over and then x to the 6th. All right. I'm going to make sure everybody has this. So pause the video until everybody's got it, and then we can move forward. This is the zero exponent property. We talked about this previously. It says for any non-zero, which is a to the 0 is equal to the number, who remembers? 1. Remember, anything to the 0 power is 1. This is one that we definitely need written down. So let's keep going forward and look at some examples here. This one should be pretty quick examples. So 5 to the 0 power, everybody. What is that one? 5 to the 0 power. Well, that equals 1. In parentheses, negative 7 to the 0 power. So that means everything inside this parentheses, which is actually only one thing, that equals 1. What about this one? We've got a fraction this time. Well, that 2 gets a 0, and that 3 gets a 0. So if they each get zeros, well, they both, it's like saying 1 over 1, right? 1 over 1, well, that's just simply 1 again, right? So the answer again is 1. Are you getting the pattern here? Anything in parentheses is going to be a 1. All of this, look at this in the parentheses. So all of this is getting a 0 on it. So it's not 3, 0, it's 3 times 0. Remember, you have to distribute it. And anything times 0 is 0. So all of these would have zeros on it. And I'm not going to write that all out. Look at all these. You need 5 different, no, sorry, 1, 2, 3, 4 zeros here in the denominator. Our answer, of course, is going to be 1, everybody. Anything inside parentheses. Now, how about this one? This one doesn't have everything in the parentheses. That negative is on the outside. Can you take a guess on what your answer would be? You can pause the video here. What do you think the answer would be for this one? Well, this one would be negative 1. We got that negative out front. It'd be negative 1. All right, this is the last one I'd like to go over with you. It's kind of interesting. Again, we have a 0 on the outside of the x and the 5 that are in parentheses. So it gets distributed to the x and it gets distributed to the 5. So let's write this out. We've got negative 2x. And this is whenever there's nothing in between it, we know that means times. So I'm going to put a little times there. And I know that everything inside here is going to be 1, right? Because anything to the 0 power is 1. Well, wait a minute. Negative 2x times 1, that's just negative 2x. You leave that the same. So that is going to be my answer. Again, I will pause. I have the teacher pause the video, making sure you have these notes down. These are pretty quick ones. Some of them are a little bit different, but most of the time, anything to the 0 power will be 1, right? So that is the idea behind this. All right, the last rule, the negative exponent property. So it says for any integer n and any non-zero number a to the n, negative n is the reciprocal. And we covered this before, remember? Reciprocal basically means you're flipping it. You're making it into a fraction and you're flipping it. Another way of looking at it is again we have that 1. If we make this into a fraction, the 1 goes up here and the a to the negative n goes on the bottom, and then the negative changes to a positive. So the base changes floors, make the exponent positive. Okay. So it basically goes from the top to the bottom floor, or from like the basement to the attic, whatever you want to say. And it changes it from negative to positive. The sign changes. And we've covered this already. This should be a review. If you don't have this in your notes, please ask the teacher now to pause the video and make sure you write it down. Let's look at some final examples here. So we have x to the negative 7th. Again, cannot have negative exponents. It says right here, only positive exponents. So I take this and I think I'm moving it down. So I move it down, I keep the base the same, and I just change the positivity from negative to positive. And then I put a 1 on top. And then I'm done. So that's it. Another one, it's the same idea. The 2 stays the same because it's the base. The exponent changes signs. And this one we could actually do, because we can do 2 to the 3rd power, right? So if we want to make this even more simplified, the 1 stays on top, and we have 2 times 2 times 2, which is 8. Again, you can take this into your calculator, 2 to the 3rd power. All right, finally, we have ones that are on the bottom here. Uh-oh. This one's in the base, so we need to move this to, this one's in the basement of the fraction, right? So we're going to move this to the top. If you move this to the top, there's going to be nothing on the bottom, so you'd actually need anything on the bottom. We just have 2 to the 4th power. It becomes positive. And you can do this again. So what would this be? This would be, let's see, 16, I believe, right? 2 to the 4th power. You can try this out. So this number is the same as saying the number 16. Last one I want to go over with you is the one where you have 2 negatives. We've got a negative here and a negative here. Well, this is just going to, you take one at a time. First, the the negative 3rd goes down. It becomes a positive 3rd. And then the 2 to the negative 4th goes from the bottom to the top floor. And that's it. And we know that 2 to the 4th power is 16. So we can rewrite this as 16 over x to the 3rd. All right, fantastic. Please have the teacher pause the video, and this will be the end of the video. Making sure that you have all of these notes written down so that you can move forward with today's practice.